Good evening, dear students. Yes. So last time we have started with structure of atom. Okay. And we have seen the synopsis. So what all things we have discussed in the synopsis part? Just I will show you. Okay. I hope yes. So this was the synopsis. Synopsis means we have seen the short important notes. Okay. So we have seen the properties of atoms. Okay, different fundamental particles. So we have seen the properties of electron, proton, neutron. Then we have discussed about the nature of electromagnetic radiation. Then the electromagnetic spectrum, and we have discussed about the quantum number. Okay, we have discussed about the quantum number. So based on that, we have seen the questions, right? So let us continue. Then we have also seen how to fill up the electrons, right? So we have seen the Aufbau principle. This is called a Aufbau principle. So how the electron filling takes place? The electron filling takes place from lower, okay, lower energy to higher energy. So the electrons get filled from the lower orbitals, okay, energy orbitals to the higher energy orbitals. Okay, so we know that there are how many elements are present in the periodic table, students? Yes, how many electrons are present? How many elements are present, sorry, in the periodic table?
118.
Yes, very good. 118 elements are present. So how we are writing the electronic configuration? Very important for PUC first year students. Okay, electronic configuration, the filling up of electrons is very, very important. So we have to follow the Aufbau principle. Okay, Aufbau principle. It states that the filling of electrons takes place from lower energy orbital to higher energy orbital. So it starts from 1s, then it goes into 2s, then 2p, 3s, 3p, 4s, okay, and so on. So like this it will follow. Fine. So so like this the electron filling will takes place. So from lower energy orbital to higher energy orbital, the electron filling takes place. Okay, fine. So let us see. So in the last class we have seen only few this questions. Okay, we'll continue with the questions. Okay, if any different type of questions come, then we will see the short notes on that. Okay, fine. So let me continue with the questions now. Okay, so we have seen the first question. Okay, we have seen the first question. It's not getting. Yes. Okay, we have seen this first question. Okay, then we have seen the second question also. Yes, we have seen this second question also. Third question also we have seen. Okay, de Broglie's wavelength. This also we have seen. Fourth one, okay, Rydberg's constant. We will see it later. Okay. Then fifth one also we have seen. Okay, how to write the quantum numbers for the outermost electron of copper in ground state. Okay. Now let us go with the sixth one. Which one of the following sets of quantum number represents the highest energy level in an atom? Okay. So which is the which of the following sets of quantum numbers? So we know that four quantum numbers are there. Which are the four quantum number? Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So we have discussed about these quantum numbers in our previous class. Okay. So here, which is the following set of quantum number which will tell you the highest energy level of an atom? Okay. Now here, when we are discussing about the orbital, so the orbital with the highest energy level. Okay. So we have to remember that when n plus L value, okay, when the n plus L value, whoever's n plus L value is high, okay, n is what? N is your principal quantum number, L is your azimuthal quantum number. So you have to find out the what n plus L value. So what you have to do? N is 4, okay, plus 0, whatever. So like this, you have to find the n plus L value for the all 4 options. Okay, whoever's n plus L value is higher, okay, highest. So it is the higher energy. That will represents what? Highest energy. Can you do it? Can you do it now? Yes, I have told you. So there are 4 options. So what you have to do? First value, n plus L of first one is what? 4 plus 0. Okay, find out. Then B option, n plus L value, 3 plus 1. Then third one, n is equals to 3 plus 2 is equals to, okay. Then fourth one, 3 plus 0. So whose value is highest here? In which option? So this is 4, this is 4, this is 5, and this is 3. So whose n? It is C.
Option C.
Yes, yes. Sinchana has also answered. It is option C. So remember that. Okay, if like this question, if they ask, okay, if they ask this type of question where they have told you to find out the highest energy level in an atom. Okay, so of a set of quantum numbers, so you have to use this n plus L value. Okay, this is plus half. Okay, just the numbers have okay, so this is plus half, plus half, plus half. Okay, S value, that is spin quantum number value, is plus half. So only the numbers have shifted. So, okay, so how you are going to find out the highest level? You have to take n plus L. Okay, take the addition, do the addition of n plus L. That is your principal plus azimuthal quantum number. Whoever's value is highest, that is the highest energy level. So option number C is our answer. Okay, option number C is the answer. Fine. Let us go for the next question. So we are seeing the principal quantum number. Okay, very important principal, all the quantum numbers. So let us go for the, if the energies of the 2 photons are in the ratio of 3:2, their wavelengths will be in the ratio of. So this we have seen. Okay, we have seen this. We know that. So we have that formula, right? So the students who are not there, so we know that energy is inversely proportional to what? Energy is inversely proportional to lambda. Okay, energy according to Planck's constant theory. According to Planck's quantum theory, energy is inversely proportional to lambda. So if E1 by E2 is equals to what? Lambda 2 by lambda 1. So if E1 by E2 ratio, if the energy is of an this photon, 2 photons is 3:2, then what will be the ratio of wavelength? It will be 2:3. Okay, so it is option number B. It is option number B. So option number B is the answer. Yes. Fine. Let us go for the next one. I think we have done this. Okay. So let us go for the next one. The correct set of 4 quantum numbers for the outermost electron of sodium is. Okay. So now we have to find out the 4 quantum numbers. Now we know which are the 4 quantum numbers. Okay. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. So what we have to do? We have to find the 4 quantum numbers for the outermost electron of sodium. Sodium is represented by what? Na. Okay. And what is the atomic number, students? It is given here already. Okay. If you don't know, okay, it is 11. So if we write the electronic configuration, so we are going to start with 1s. Okay. So it is 1s2, 2s2, then the electron filling will go into 2p. So in p, the maximum number of electrons filled are 6. Okay, so 6, 7, 8, 9, 10. Okay, already 10 electrons are filled. Now only 1 electron is filled. So it will go into which orbital? 3s1. Okay, So 1s2, 2s2, 2p6 and 3s1. So what they have asked? They have asked us to find out the 4 quantum number for the outermost electron. So which is our outermost electron? 3s1. Okay. Can anybody tell me what is the answer? Which are the 4 quantum numbers for 3s1? We have solved this, okay, for copper. So different examples we have taken in the last class. So can anybody tell me what is the answer? How we are going to find out? So I have written the electronic configuration also. Okay. So 3. What is N? N is our principal quantum number. What it represents? It represents the main shell. Okay. Main shell. So here, which is the main shell? The main shell is 3. Okay. The main shell is what? 3. Okay. So N is equals to 3. N is 3. Then L. L is what? It represents the shape of the orbital. It will start with what? L is equals to 0, 1, 2, 3. If it is 0, it is S. If it is 1, P, then D and F. Which is S is what? S is a S means here it is 0. So what is L value? L is 0. What does azimuthal quantum number states? Yes, what is the principal quantum number? It describes the main shell of the orbital of the electron. Okay, what does your azimuthal quantum number tells you? It tells you the shape. Okay, it tells you the shape. So which are the different shapes? We have discussed this, right? And the L value, it starts from 0. If L is 0, that means what it is? It is S orbital. Okay, if it is 1, P. 2, okay, D orbital. Okay, P means dumbbell shape. D means double dumbbell shape. Okay, like that. So now here it is what? So L is 0. S orbital means it is 0. Now M. M is what? M is again here 0. Okay, M is 0. It represents the magnetic quantum number. Okay, M is the magnetic quantum number. Then next is what? D. Sorry, that is S. Okay, spin quantum number. Spin quantum number is plus half or minus half, any one. So which is the answer? It is option number D.
D, ma'am.
Yes, option number D. Okay, so like this, we are going to find out the correct set. Okay, so like this, the question can be asked. They will give you any element. Okay, they will give you any element and they will ask you to find out the this what quantum number. Okay, all the 4 quantum numbers. Fine. Let us go for the next one. Impossible orbital among the following is. So which is the impossible orbital among the following? A, 2s, B, 3f, then C, 2p and D, 4d. So which is the impossible orbital among the following? So we have seen the different, okay. So you might have seen the different orbitals. Okay, so when you see the filling up of electrons, so if you want, I will show you the okay. I hope you are able to see the screen now. Okay, so can you see from here which is the impossible orbital? So there were 4 options. Okay, I'll tell you. The 4 options were 2s, okay, 2s, which is not possible, they were asked, okay, 2s, then 3f, 2p, and 4d. So you can see here, okay, filling of electrons, okay, so 2s is possible, 2s is possible, then 3f, can you see 3f? No, 3s is not possible, okay, so 1s, 2s, 2p is possible, 3s, 3p, 3d is possible, 4s, 4p, 4d, and 4f is possible. 5s, 5p, 5d and 5f orbitals are possible. 6s, 6p, 6d, 7s and 7p. So these are the orbitals which are possible. So which is the orbital which is impossible? It is 3f.
3F.
Yes. Yes. Option number B. Okay. Option number B is the correct answer. Okay. Option number B is the correct answer. So it is 3f. So 3f orbital is not possible. So these are the sequence of orbitals. Okay. Where the electrons fillings will takes place. How you are going to fill up the electrons? It is through the above principle. Okay. It is through the above principle. Fine. So now let us continue with the questions. Next question. Okay, so this is a question. The electronic configuration of Cu2 plus ion is. What is the electronic configuration of Cu2 plus ion? What is Cu2 plus? Copper in +2 state. Okay, copper in +2 state. They have asked what is the Okay, so they have asked what is the electronic configuration of copper +2 ion. What is the atomic number, students? Anybody knows what is the atomic number?
29, ma'am.
Yes, 29. So shall we write the, it is not. Okay, let us write the electronic configuration. Why it is not getting zoomed? Okay, fine. Let us write the electronic configuration. Okay, so it will start, the filling up of electrons starts from 1s. Okay, it will start from 1s. So 29, copper in 29. Okay, so what do you mean by copper +2, students? Copper +2 means what? They have lost 2 electrons. Copper +2 means what? +2 means there is a loss of electrons. Okay, how many electrons are lost? 2 electrons are lost. 2 electrons are lost. Okay, so +2. And if it is minus, means this is in cation form. Okay, copper is in its cation form. Okay, so it is in Cu +2 means 2 electrons are lost. So first we will write it for copper. Okay, let us write it for copper. So start. So copper electrons. Okay, it will start from what? 1s2, 2s2, 2p, 6, 3s2. Okay, so how many it becomes? So 2, 6, 7, 8, 9, 10, 11, 12. Okay, then 3, 3p. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6. Fine. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this represents what? This will represent which noble gas? This will represent the noble gas argon. Okay, it will represent your noble gas argon. Okay, argon, you can write complete like this. Okay, completely you can write, or you can write argon. Okay, argon, and then you have to continue. So argon is 18. After that, next comes what? After 2p, 3d. Okay, so next electrons will enter into 3d orbitals. So how many in d orbitals, how many maximum electrons it can be filled? Yes,
10.
10 electrons. Very good. So the maximum number of electrons can be filled are 10. So let us write C, 6, 7, 8, 9, 10, 11, 12 and this 6. So 18. So still we can fill up there 10. Okay, so it becomes 18 plus 10 is 28. Okay, 28. And then the electron goes into 4s1. So this is for copper. Okay, this is for copper 29. So let us write it for copper +2. So they have asked us for copper +2. Okay, so we can write like this also: argon 3d10 and 4s1. Or okay, we can write like this. If you want, you can write completely the electronic configuration, or you can write like this. Okay, argon 3d10 4s1. Because we can write the nearest noble gas. Okay, nearest noble gas. So let us write for copper +2. Copper +2. Okay, so what will happen? one electron will be lost from here. Okay, this one electron, and from here one electron. So what it will be? It will be argon 18, okay, and 3d9 4s 0. Okay, because no electrons are left. So which is the answer?
Option B, ma'am.
Yes, option B. Argon 3d9 4s0. Okay, when plus 2 means what? 2 electrons are lost. If it was plus 1, so then what it would be? It will be 3d10 4s0. Okay, like that. So how many plus means the electrons are lost. Minus means electrons are gained. Okay, the electrons are gained. So this is the electronic configuration. So for PUC first year, the electronic configuration is very important. So please practice the electronic configuration of chromium and copper. Okay, both chromium and copper. So it is very important. So please practice the electronic configuration of copper and chromium. Okay, fine. Let us go for the next one. And also zinc. And also zinc. Okay. Next question. Okay. So which of the following sets of ions represents the collection of isoelectronic species? Okay. Which of the following sets of ions represents the isoelectronic species? Now, what do you mean by isoelectronic species, students? Anybody knows? What do you mean by isoelectronic? Anybody have heard about isoelectronic? Isoelectronic. Okay. Iso means what? Same. Okay. Iso means, the word iso means same. Electronic means same number of electrons. Okay. Same number of electrons. So isoelectronic species are those species which are having same number of electrons. Very important. Mark this as important definition. Okay. This can be asked in your structure of atom as well as redox reactions. Okay, not redox reaction, for classification of elements, for classification of elements and periodicity. Okay, so there is also this particular word isoelectronic species. So you have to know the meaning of this word isoelectronic species. So what do you mean by isoelectronic? Isoelectronic means same number of electrons. Okay. So the species having same number of electrons are termed to be isoelectronic. Okay. Now what they have asked, they have given you 4 different sets. Okay. So you have to see which is the correct set which is having same number of electrons. Okay. So let us find out. Okay, let us find out. So K plus, okay. K plus means what is the, can anybody knows what is the atomic number of potassium? Anybody knows
19.
the 19. Okay, atomic number of potassium is 19. Okay, so now here K plus means what? One electron has lost. Okay, 19. What does 19 represent? Atomic number. Atomic number is nothing but number of protons. Okay, remember that. Atomic number, how you are going to find the number of protons? That is equal to atomic number. Whatever the atomic number is there, that is your number of protons. Okay, then what is your this? How you are going to find the next is how you are going to find the electrons, number of electrons? How you are finding the number of electrons? How you are going to find the number of electrons here? So which is the formula? So number of electrons, okay, and this number of neutrons, number of neutrons. So these are the species where you have to calculate, right? So now here, when you're finding out the number of electrons are, you are going to now here plus. Plus means what? One electron is lost. Okay, one electron is lost. So the number of electrons here is how many? It is 18 because plus represent one electron is lost. Now, when you're finding out for Cl, same way when you are finding out for Cl, how you're going to find it for Cl? Chlorine, what is the atomic number?
17.
17. Okay. Then here chlorine is 17. So minus Cl minus. Cl minus means what? One extra electron. Okay, one extra electron. So the number of electron here is how much? It is 18. Okay. So the number of electron is 18. So let me write. So K plus it is 18. Then Cl minus is 18. Then Mg. What is magnesium? Magnesium, it is
12.
yes, it is 12. Very good. So magnesium is 12. Okay, plus 2 means 2 electrons are lost. Okay, 2 electrons are lost. So it will be 10. So Mg 12. So 2 electrons are lost. So it is 10. Then scandium. Scandium is 21. Okay, scandium is 21. So scandium plus 3. Plus 3 means it will be how much? It will be 18. Okay, 18. So your magnesium is 10. So it is not having same number of electrons. So first option is wrong. Okay, first option is wrong. So same way, let us find it for next one. Okay, let us find it for next series. So sodium is 11. Okay, so the number of electron, it is plus 1. So the number of electron is 10. Then calcium is Ca plus 2. Okay, calcium is 20. Okay, calcium is 20. So plus 2 means the number of electrons lost is 2. So it will be 18. So here 10, here 18. Then scandium is how much? Scandium is 21. Okay. So plus 3. Again, the number of electrons are here 18. Okay. Next is fluorine. Okay. Fluorine is 9. So plus 1 electron. Okay. Because it is minus. So it will be 10. So here again, they are not same. The number of electrons are not same. So this is also wrong. B option is also wrong. Let us go for the C option. Potassium plus. Okay. So it will be again 18 electrons. Then calcium plus 2. Calcium plus 2 is how much? The number of electrons
18.
here you can see 18. Then scandium plus 3.
18.
Okay, it is 18. Then chlorine is
18.
17. So minus means one extra electron. So 18. So option number C is correct. Okay. So isoelectronic means what? They are having same number of electrons. Okay. Same number of electrons. So yes, option number C is correct. Fine. Among the elements from atomic number 1 to 36, the number of elements which have an unpaired element in their S subshell is. Okay. Among the elements from atomic number 1 to 36. Atomic number 1 to 36. The number of elements which have unpaired electrons. Okay. How many unpaired electron? Unpaired electron means what, students? Unpaired means they are not paired. Okay. In their subshell is. So when you calculate, so A option is 4, B 7, C 6 and D 9. Okay. So here, when you find out when you write the electronic configuration for all the elements from 1 to 36, so there are 6. Okay, there are 6 elements which are having unpaired electron in their S subshell. Okay, which are the elements? First one is hydrogen. Okay, it is having 1s1. Then is your lithium, okay? Lithium, which is having electronic configuration 2s1. Okay, this is the outermost electronic configuration. Then is your sodium, which is having 3s1. Okay, so this is in the S. Next is your potassium. Potassium is how much? It is argon 18 plus 4s1. Next is your chromium. Okay, chromium is 24. So it is argon 3d5 and 4s1. Next is your copper. Okay, next is your copper 29. That is argon 3d10 and 4s1. So these are the 6 elements. Okay, remember that. So which are the 6 elements? So these are the 6 elements which are having unpaired electron in the subshell. Unpaired means what? Only one electron is present in the S subshell. Okay, in the S subshell, only one electron is present. So how many there are? 6. There are 6. Okay, let us go for the next one. The statement that is not correct. The statement that is not correct is angular quantum number signifies the shape of the orbital. B, energies of stationary states in hydrogen-like atom is inversely proportional to the square of the principal quantum number. Then total number of nodes for 3s orbital is 3. And D, the radius of the first orbit of He plus is half that of the first orbit of hydrogen atom. So which is not correct? Okay, which is incorrect among the following? Can anybody tell? Okay, here when we were discussing this particular question, okay, where it went, isoelectronic species, okay. So here, just remember, okay, this particular formula. So suppose you have a element lithium, okay, suppose you have a element lithium. Lithium atomic number is 3, okay, lithium atomic number is 3 and its mass number is 7. So this is what? This is your atomic number, okay, this is your atomic number. And okay, this is your atomic number, which is represented by what? It is represented by Z. Okay, it is represented by Z. And this is your mass number. This is your mass number. Mass number. Okay. Now here, now what you are going to do? I told you, okay, number of protons. How you are going to calculate the number of protons? Atomic number. Okay, the atomic number only is your number of protons, whatever the atomic number is there. And what is the number of electrons? Number of electron is also same. Okay, the atomic number. Now only now if there is a neutral charge, that is same as equal to atomic number. If it is plus, then subtract one number. Okay, that is 3 minus 1 will be 2. Now if it is plus 2, means it will be how many electrons are there? Plus 2 means only one electron. So plus means you have to subtract whenever you are finding the electrons. Okay, and if there is minus, you have to add. Whatever the number will be, same, plus or minus. So that will tell you the number of electrons. Then number of neutrons. How you are going to find the number of neutrons, students? How you are going to find the neutrons? So neutrons are what? The total number of protons. Okay, that is mass number. Okay, mass number. How you are going to get mass number? Mass number is protons plus neutrons. Okay, proton plus neutrons. So here, if I tell you what is the number of protons, the number of protons is what? The number of proton here is how much? It is 3. Okay, P is equals to 3. Then number of electrons are 3. Okay, electron E, so it is also 3. Then neutrons. How you are going to find now neutrons? We have mass number, we have protons. So what we have to do? We have to subtract mass number minus the protons. That is 7 minus 3. That is 4. So the neutrons are 4. Okay, like that. So remember this also. Very important. 2 marks question or 3 marks question. They can give you any one element. They will give you any one element and they will tell you to find out the this what number of protons, number of electrons, and number of neutrons. Okay. So number of electrons, protons you can find. Number of neutrons, how you are going to find? Mass number is equals to proton plus neutron. Remember this formula. And when you want to find the neutrons, you have to subtract your mass number minus protons. That you will get the neutrons. Okay. So this is the very important. So in theory also this question is asked. Okay. So I just thought of telling you. Okay. Let us go back. So where we were, okay, this particular statement. Okay, we were to this particular statement. Okay, which is the not correct among the following? Yes, can anybody tell me which is not correct? The first statement, okay, this angular quantum number signifies the shape of the orbital. It is correct statement. Okay, angular, that is angular or it is azimuthal. Okay, angular or it is azimuthal quantum number. It signifies the shape of the quantum orbital. So this is a correct statement. Then energies of the stationary state in hydrogen like atom is inversely proportional to the shape of the principal quantum number. Okay, so this is also a correct statement when we see the this principal quantum number. So when you study the this, okay, so when you study the what you say principal quantum number, okay, thoroughly, so there it determines the shape, this principal quantum number, it tells you about the size. Okay, it tells you about the size of the size and energy. It tells you about size and energy. Okay, it tells you about size and energy. Principal quantum number, it tells you about the size and energy. So if hydrogen atom, and this is there, hydrogen atom and all, so that is inversely proportional to the square of the principal quantum number. So this is also a correct statement. Option number B. Okay, this is also the correct statement. Then C, option number C. Total number of nodes for 3s orbital is 3. Okay, the total number of nodes. Now, what do you mean by nodes? Okay, whenever you want to calculate the nodes. Okay, nodes, what do you mean by nodes? Anybody knows what is nodes? Node means what? So it is the region. Okay, it is the region or the space. Okay, the region or the space. Now electrons are there. Okay, there is a electron. Now the electrons are filling. Now the distance between the spaces. Okay, the empty space or the region. Okay, where you cannot find any electron here. Okay, now here. Now when we write the electron in the center, what is present? Okay, here the nucleus is present, right? So nucleus we represent by positive sign. Then the electrons are revolving around this. Now the space here in between the electrons and the nucleus, here the space, okay, or the region, it is called as the node, okay. And here the probability, okay, the probability to find the electron here will be 0. You cannot find the electron here. So that is called as the node, okay. So now when we find out the node, so the total number of nodes. So whenever we are finding out the total number of nodes, so for any orbital, it will be calculated by, okay, remember this, n minus 1. Okay, so whenever we are calculating the number of nodes, so please make a note. Whenever we are calculating the number of nodes, okay, we are going to use the formula n minus L minus 1. We know what is n. N is the principal quantum number. L is what? Angular or azimuthal quantum number. Now we know how to find the value of n, how to find the value of L. Now here what is given? 3s is given. So what is the n? N is 3. And L is what? L is 0. Right? So if I put the value here, n is 3 minus 0 minus 1. Okay. So how many nodes are possible for 3s orbital, students? It is 2. And what they are given? The total number of nodes for 3s orbital is 3. So this is a wrong statement. Understood? Understood? This question is clear. So please remember this, okay? Make a important note. So whenever you have to calculate the number of nodes, which is the formula, number of nodes can be calculated as n minus L minus 1. N is what? N is the principal quantum number. The main shell. Okay, this represents the main shell. Okay, then L is what? Shape. Okay, S is nothing but L is equals to 0. 0 represents your S orbital. If it was P, then L value will be 1. If the it was D, if it is 3D, D means L is equals to 2. Okay, remember this. So whenever you want to calculate the number of nodes, it is N is equals to L minus 1. So what it is given here? Total number of nodes for 3s orbital is 3, but the correct answer is 2. So option number C is incorrect statement. So which is our option? Option number C. Okay. So option number C is the correct statement. Is it clear? Is it clear up to your?
Yes,
Any
ma'am.
doubt? Okay. So please make the note. Okay. Number of nodes. How we have to calculate? N minus L minus 1. Okay. Let us go for the next one. The two electrons have the following sets of quantum number. So there are two electrons. Okay, two electrons are there. Suppose the two electrons are, okay, like this. Any two electrons. Okay, now one electron, the set of quantum number is, so I'll write here. So it is P is equals to 3, 2, minus 2 and plus half. So this is one set. And for Q, another electron, it is 3, 0, 0 and plus half. So which of the following statement is true? A, P has greater energy than Q. B, P and Q represent same electron. C, P and Q have same energy. And D, P has lesser energy than Q. Okay, so these are the 4 options. Now, P, okay, can you tell me from this P and Q, okay, P is equals to 3, means what is the, can we write the, this orbital? Okay, so the main shell is 3. The main shell is 3. N represents a principal quantum number. When L is equals to 0, this is what? This is N, L, this is magnetic quantum number, this is spin. Okay, let us find out the, which are the two electrons. Okay, then L is equals to 0, 1, 2 and 3. So L is equals to 0, it is S, P, D and F. So L is equals to 2 means it is D. So 3D. Okay, 3D. Then, so the first orbital is 3D. So from first two values only we can understand. Now, this is P is equals to 3D. Then Q, which is Q, again it is 3 and L is 0 means it is S. Okay. Can you tell now which is greater in energy? Which of the following statement is true? So 3D. Okay. 3D is highest. Okay. 3D is greater in energy. When we see, okay, first comes 1s, then 2s, okay, then 2p, then 3s, then 3p, then 3d. So when we write the electronic configuration, 3s is less in energy. We know, according to above principle, when we are filling up the electrons, the electron filling takes place from lower energy orbital to higher energy orbital. So which is the lower energy? 3s. So when we see the following statement, which is correct now? Can you
Option
apply?
A.
Option A. P has greater energy than Q. Yes, everybody, is it correct? Option number A is correct. Okay, Sinchana has answered as A. Okay, so if you see the four statement among this, which is correct, it is option number A. Okay, because when we see P and Q, okay, So 3D is having greater energy than the Q. So option number A is correct. Okay, I hope this is clear. Okay, shall we go for the next one?
Yes, ma'am.
Okay, so this also is about nth Bohr orbital. Let us see next one. Okay, so or this Rydberg's we will do later. Okay, we will solve of quantum numbers first. See, you have seen so many different types of questions they have asked on quantum numbers, right? So so you know how important is quantum numbers. Okay, so let us see the next type of question. Consider the following sets of quantum numbers. Which of the below setting is not permissible arrangement of electrons in an atom? No, means what? What is the question? Which is the following set of quantum number? Okay, which arrangement is not possible? Permissible means not possible. Not which set of quantum number is not possible of an electron in an atom. Now we know what is N, what is L, what is M, and what is S. So yes, try to answer this. So these are the four options. Okay, so which set of quantum number? Okay, it is not possible. Which is not possible? So just see, apply. 16th question. So here, so when this, okay, for this is what? First one, A, it is 4s. Okay, 4s. So 4, number main shell is 4 and L is equals to 0. M will have the values of so M will have the value of 2L plus 1. Okay, 2L plus 1. So how you are going to find the M values? 2L plus 1. So 2 into 0 plus 1. So 2 0 is 0 plus 1. So it will be two values. So 0 and 1 values are possible. So this is correct. Then second one is what? B. For B, 5. Okay, 5 is the main shell and 3 means what? L is equals to 0, 1, 2, and 3. So it is S, P, D, and F. So it is 5F. Okay, 5F. B is 5F. Then C is 3 and 3D. 3D. Okay, 3D. So here, if we write, so L value is 0. Okay. So here, if we find out for M value, how you are going to find the M value? Remember the formula to finding the M value, it is 2L plus 1. Okay, 2L plus 1. So 2, here what is the L value? It is 3. So 2 3s are plus 1. So it is 2 3s are 6 plus 1, 7. So 7 possible values are there. Okay. So it is 0 plus or minus 1 plus or minus 2 plus or minus 3. Okay. So there are how many possible values? 7 possible values are there. So 0. This is also correct. Then C. Option number C. So it is 2. So find out here 2L plus 1. So 2 L value is how much? L value is 2 plus 1. So 2 2s are 4 plus 1 is 5. So 5 possible values are there. Which are the 5 possible values? The 5 possible values when L is equals to 2 is minus 2. Okay. Your L is equals to 2. So minus 2 plus minus 1, 0 plus 1 and plus 2. So here, which is the possible arrangement? So for a given value, M cannot be, okay. So this is also correct. So this is also, C option is also correct. Now, when we see the D option, again, what we are going to find out here, N is equals to 3. Okay, and L is equals to 2. So which it is? So L is 0, 1, 2, and 3. So it is S, P, and D. So it is 3D. Okay. So M value is what? 2L plus 1. So 2 into what is L? M value, sorry, L value is how much? L value is, L value is 2. So 2 into plus 1 is 2 to the 4 and 5. So which are the 5 possible M values? M is equals to -2, -1, 0, +1, and +2. So, but they have given M value as -3. So, -3 is not there. Okay. So, option number D. So, this is not possible. So, option number D. So, when we are finding the M value, so which is the formula we have to use? M is equals to 2L plus 1. Okay. So, for first one, okay, which are the possible L values? It is 0, -1, 0, and +1. Okay. So same way with this, like this one only. Okay. So so we are going to use the formula 2L plus 1. So by using this, option number D is the incorrect. It is not possible because the M values are in between -2, -1, 0, +1, and +2. So these are the possible 5 M values. Okay. But this is -3. So option number D. This is not possible. So the option number D is the set which is not possible for the given electron in an atom. So option number D is incorrect. Next one, same way, the correct set of quantum numbers for the unpaired electron of chlorine atom is. So they have asked for chlorine. Okay, find out for chlorine. Chlorine atomic number is 17. Now here you can see in the last time they have given the atomic number. So you need to know the atomic number of some of the elements. Now here they have not given the atomic number. So chlorine is 17. Write down the electronic configuration 1s2, 2s2, 2p6, 3s2, and 3p5. See 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so 3s2, 3p5. So the electronic configuration. So the unpaired electron is present in what? It is 3p5. Okay, so unpaired electron of chlorine atom is in which? 3p5, right? 3p5 means what? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so here in 3p5, the unpaired electron is present. So what is the, so for 3p5, write down now, what is N? What is the N? N is 3. L. L is what? L is equals to 0, 1, 2. So SP. So L is equals to here 1 because p orbital value is 1. Then M, which are the possible M values? So 2L plus 1. So L is 2 into 1 plus 1. So 2 ones are 2 plus 1, 3. 3 possible values are there. So which are the 3 possible values? That is +1, 0, and -1. Okay. Next, what is S? S is what? It is plus and minus half. Plus or minus half. Okay. So which is the possible set? So it is 3, 1, 3, 1, 1, and plus and half. So which is the answer? Can anybody tell?
Option D.
Yes, option number D. So please remember the formulas are very important. So for finding out M, it is 2L plus 1. So use this formula and then see. So these are the possible values. So whenever you are finding out M, M is nothing but 2L plus 1. Okay. So it is represented by L. So whenever L value is there, L value, so that will be it is between minus L, okay, L minus L0 and plus L, okay, like this. So based upon the L value. So now it is how many they were? 3. So 3 means +1, 0, and -1. And S value is plus or minus half. So it can be plus half or minus half. So the correct set of quantum number for the unpaired electron of chlorine atom is option number D. So option number D is the correct answer. Okay. Okay, one question. Two particles. Okay, there are two particles A and B. and they are in motion. Motion means what? They are moving. Okay, they are moving. If the wavelength associated, so wavelength associated with A is 33.33 nanometer, and the wavelength associated with B, whose momentum is 1/3 of A. Okay, the momentum of B is 1/3 of A. So you have to uh, find out the here. Okay, now here what all is given? So lambda A is given, that is the wavelength. So you have to find the wavelength of the B. What they have told, the momentum is 1/3 of A. So your lambda is what? It is 33.33 nanometer. So we have to convert it into meter because the answer is in meter. So how we are going to convert it into meter, students? How we are going to convert? So here, when you are converting into meter, okay, from nanometer, you have to multiply by 10 raised to minus 9. So it is 33.33 into 10 raised to minus 9 meter. Okay, 33.33 into 10 raised to minus 9 meter. Now we know that lambda is equals to h into PA. Okay, so that is your momentum, okay, into momentum. Now here lambda. What is momentum? Momentum is equals to this, what? Uh, M into V, okay, M into V, that we have here. Okay, so let us find out. So we have taken from the Broglie's, okay, de Broglie equation, that is lambda is equals to Planck's constant by momentum. So by using this, what they have told, that is momentum is how it will be for your lambda B. So we have written the momentum for this A. Let us write for B. So lambda B is equals to h by momentum is 1/3. Okay, so multiply divided by 3. So how it will be? So we to okay. So if we, so this is equation 1, this is our equation 2. From equation 1 and 2, what we are going to get? Just divide 1 by 2. So it will be lambda A by lambda B is equals to lambda A by lambda B is equals to HS gets cancelled. It will be 1 by 3. Okay, it will be 1 by 3. Okay, so this and this get cancelled. So this will be 1 by 3. Then just find out now. So lambda B, what you have to get? So lambda B is equals to, what is lambda 1? So just cross multiply. So lambda 1 into 3. So that is 33.33 into 10 raised to minus 9 into 3. So find out how much answer you're getting. Just check. 33.33 into 10 raised to minus 9 into 3. So what they have told, there are two particles A and B and they are in motion. Okay, so wavelength of one is given, that is 33.33. And the second wavelength, how they have told, that is the momentum is 1/3. So we know that, okay, what is momentum? We know what is momentum. Okay, so momentum we have found out by putting the so mass and velocity is nothing but your momentum, right? So what we have done, so here, that is h by, is equals to momentum. So that is 1/3. So by relating it, so what we are going to get, we are going to get the answer as 9.99 into 10 raised to minus 9 meter. So if I transfer the this, it is approx 1. Okay, 1 into 10 raised to minus 7 meters. So what I'm going to transfer? I'm going to transfer the this, okay, sign that side. So it becomes 1. 1 into 10 raised to minus 7 meters. So option number D. Okay, option number D is the answer. So just go through Got it? So what we have done here, so your 10 raised to minus 9 is there. So what we have 99.9 is nothing but 1. Okay. And what we have done, we have shifted the decimal. Okay. We have shifted the decimal, okay, to the left hand side. So it becomes 10 raised to minus 7. So option number D is the answer. So just we have related the formula. Is it clear? So these were some of the questions. Okay, so remaining questions we'll be discussing in the next class. So we are going to see what is photoelectric effect, what is Rydberg's constant. We are going to study something called as hydrogen electron. Okay, so these all things are remaining. So regarding that, we are going to see the questions in the next class. Okay, hydrogen atom, based on hydrogen atom. Okay, quantum mechanical model. So these all questions will be that is line spectrum of hydrogen. So based on this, the questions we'll be discussing on the next class. Okay, I hope today's questions are clear. So we have seen different types of questions on quantum numbers. Okay, so these are all very important questions. So I hope you have understood all the questions. So similar questions, if you find anywhere, okay, please practice those questions. Okay, so remember all the important formulas, whatever I have told you. So based on that, please try to solve some more questions. Okay, it will help you to understand it more. Okay, so by this, I shall end the session here. Okay, so we'll meet in the next week. Thank you.